The overall goal of this procedure is to create atomistic models of helical nanosprings and nanoribbons using an open source code for molecular dynamics, or MD, simulations. This video describes how to prepare silica glass nanospring models by first preparing an appropriate atomistic bulk silica input file along with the open source nanospring carver program files. The second step is to start MATLAB on a Linux PC and use the nanospring carver graphical user interface to generate a desired nanospring model. Next, the nanospring carver results are verified in an open source visualizer. The final step is to use the results in MD tensile simulations of nanosprings. Ultimately, a variety of well-defined and scalable nanohelical models can be effectively generated for MD simulations toward materials innovation research.
I first came up with the idea of using this method back when I was performing molecular dynamic simulations of nanostructures, such nanowires and others. As you may know, spring-like materials are very abundant in nature, and so it's important to try and study such geometries, and especially for applications that have to do with energy harvesting, hydrogen storage, and biological sensing and others. And currently there are commercial packages and codes available in the market. However, they're quite limited in the types of geometries you can create, and so atomistic helical models are not readily easy to accomplish. So we hope that these type of efforts help with future studies.